you a different way to add fractions with unlike denominators. If I have the following fraction, 1/4 and 1/5, and I make something similar to this. I want to have equivalent fractions for 1/4. And in order to do that, I would say times 2, and that would double it, times 3, that would triple it, but they would all be equivalent fractions. Now, I see some confused looks. It's fine. Just stay with me. So if I were to take 2 times 1/4, you take 2 times the top number, which would be 2. 2 times the bottom number is 8. And then we have times 3. I'm going to just make a little line here since I'm getting way off on my drawing. 3 times the top number is 3 times the bottom number. 4 times the top number. And 4 times the bottom number. And then we go with 5. 5 times the top. 5 times the bottom. And then we do the same for the other number. We already have 1 because 1 times 1/5 is 1/5. So you take 2 times the top number is 2. 2 times the bottom number, 10. Separate them. 3 times 1 is 3 times 5, 15. 4 times 1 is 4 times 5 is. And then draw my line. I'm going to confuse myself and you guys with the same color lines here. Let's do this way. There we go. And then 5. 5 times the top number is 5 times the bottom number, 25. Now, if I wanted to add these two fractions together, I would have to find common denominators, right? So now I'm going to look at my list of fractions and see where I have the same denominators. Do you see an 8 under the 5? No, so let's just cross that out. Do you see a 12 under the 5? Nope. Do you see a 16 under the 5? Do you see a 5? Or a 20 under the 5, sorry. Yes. So if I were to add 1/4 plus 1/5, what could I change those fractions into? Yep, I could change it to 4/20 plus 5/20, which would give me common denominators, right? So 4 plus 5 is 9, and then you keep the denominator the same when you add, so my answer would be 9/20. Some of you were giving me kind of a funny look at the beginning as far as equivalent fractions. Yeah, we've been doing the GCF thing, the LCM, the upside down birthday cake. I'll show you. You'll remember. It's been too long. This was 4/16. If we start with the biggest number, five and 20, what goes into both those? 5 goes into both. 5 goes into 5. 5 goes into 20. Is 5/20 the same as 1/4? Yeah. Another way you can tell if they're equivalent, you can do that with each of the numbers. Another way you can tell if they're equivalent is You don't have to make a chart like what I made. You can do it this way. That's times 2. Do we get the same answer? You do it times 3. Well, that wouldn't work on that. I've been gone too long myself. Do we also have that? Yeah, we call those equivalent fractions. That means that 1/4 of a candy bar, I could also break it into 20 pieces. If I had 1/4, 5 of those would be 1/4. I'm going to have you guys work with a partner on your problem set. I'm going to show you, we'll do the second problem together. So first, let's do this. Let's write the problem out on 1B problem set, because I just went over the first one. 2 3/4 and 1 2/5. So 2 3/4, bless you, plus 1 2/5. Now you can make this chart on your desk if you want. I probably should make a manipulative for you guys to use. What 2 fractions are we going to deal with? Don't even worry about the whole numbers right now. They don't matter. So what fractions are we going to deal with in this problem? What are we working with? Okay, so we're going to start with 3/4 and 2/5. If you want, you can go ahead and just draw a thing like this. Sometimes you may need more than 5. It just depends. So what would this one would be times 1? What would this one be times? What would the next line down be? Times 2 times 5. And you're going to take, how are you going to solve it now? What am I going to do? Which would be 2 times 3 is 6, and then 2 times 4 is 8. And then on this one, 2 times 2 is 2 times 5 is. Okay, I want you to finish that. Do 3, 4, and 5 on your desk or wherever you're writing it. And I'm going to come around, I'm going to look at your fractions. I want you to circle the ones that you think are going to be the 2 fractions you're going to end up using for the problem. Okay? Okay, you guys look like you're doing a really good job. You're catching on quickly to this process. Under 3/4, raise your hand and tell me what you had with next to your 3. 9/12. Okay, and 9/12. And under 2/5. And under the next to the 4. And 5.
I got 16/20.
And
26.
And then we start with our fraction over here. 8. Do you see any 8s over here? Under the 5? Get rid of it. Do you see any 12s over on the right? Get rid of it. Do you see any 16s on the right? Get rid of it. DC and 20s on the right. Yes, we found a match. So in this problem, we're adding 3/4 plus 2/5. That's the same as adding what? What would 3/4 plus 2/5 be the same as also adding? And 15 plus 8 equals, and then that stays 20. Well, now we have a problem. What is our problem here? Let me double check, though. I need to make sure that they don't want you guys to leave that as improper for right now. No, they don't want you to. Okay, so what's the problem? Tariana? 23 is bigger than 20, so what kind of fraction do we call that? What do we call it? We call it improper fraction. So here's what we're going to do. I'm going to have you guys do the rest of your problem set page, making these charts on your desk, and finding your denominators and adding them together. So this is what I'm going to expect to see on your problem set. I'm going to expect to see that. So we're going to do all of the first step first so you guys can have practice doing that, and then we'll talk about what to do with an improper fraction and that whole number in the front. Okay? So for right now, you're going to finish the rest of the problem sets, and this is what I'm going to be looking for next to each problem. When I walk by your desk, I'm going to be looking for something that looks like this. So I know where you're getting your answers from. Does that make sense? You can work with your neighbor to finish the problem set. Do not give me the answer yet. This is all I want to see again right here. And then we'll talk about what to do with an improper fraction. Yes, ma'am. No, just that front page. Good question. Just the front page for right now. We'll do all of the first step first on every problem, and then we'll be looking for improper fractions to try to change those. Okay, so we have the problem 23 over 20. This is very easy. When you look at a fraction, it's also a division problem. A fraction is always a division problem. Again, a fraction is always a division problem. The top number goes inside the box, the bottom number goes outside. So the numerator goes in the box, the denominator goes outside. How many times does 20 go into 23? One time. 1 times 20 is 20. I have a remainder 3. How do I make that as a fraction? Okay, what do you think? What's my denominator, my original denominator? 20. So you're going to keep the denominator. What do you think is going to go on top? Good. The 3 will go on top because I have only 3 out of 20 left, right? But I do have one whole, don't I? So that becomes what we call a mixed number then. What were my 2 whole numbers on B? Okay, so 2 plus 1 plus 1 and 3 over 20. Let's do our whole numbers first. 2 plus 1 is? 3 plus 1 is? 4, and then bring down the fraction. Now, can we reduce 3/20ths? Can I reduce 3/20ths? You can't reduce 3/20ths because in order to reduce it, it has to have the same number that goes into both, besides 1. So your answer for B is 4 3/20ths. Okay, guys, remember, look, when we did what goes into both those? That's the same number that goes evenly into both. Okay, 1's the only number because 3 doesn't, right? So that's the reduced form. Now, if you've paid attention and you've drawn on your desk, then your answers will be right. If you've looked at it, let me clear this here. Some of you are thinking that you can do this little number right here and it doesn't work. Was that the same answer I just got? 23 over 20th? 20? No. It doesn't matter if you find a common denominator. When you find a common denominator, what happens to your numerators? Do they stay the same? What happened to your numerators as you went through your list? They changed also, didn't they? So if you think that you can just find what both of these go into and then add the top ones, you're going to get an F on your very first math assignment. Okay, you got to do it the way I just showed you how to do it. And for the people who were doing it on their desk the way they were supposed to do it, you're getting it all right. For the ones who weren't, you're all wrong. So you might want to check with your neighbor to see how to do it the right way if you weren't paying attention. So I'm going to have you finish just this problem set, A through H. Some of you are running into the problem of you got to 5, you didn't have a match. Just keep going, and as you keep going, keep looking at both columns to see if you have a match yet, okay? Once you learn how to do it this way, then I'll show you a way that I think is the easiest way for me, but that's not how they want me to show you today. So, your assignment is A through H. You know how to do it on your desk. Just a problem set, A through H. We've already done B. I kind of went over A with you, but I didn't add the whole number to the front, so any questions before I let you just get going on your own? Yes, ma'am. I don't know if it's going to be tomorrow. You guys kind of have to get used to doing it a certain way, you know? I'm not sure. Well, this is a happy day. Yes, ma'am. If you get stuff done well with a partner, you can work with a partner. If you feel like you're not quite getting it, just your neighbor. If you feel like a neighbor slows you down,